I'm going to go through the 2017 paper 1, question 1 here. This question is on completing the square. It's an algebra question. So a little bit messy part A to do with fractions, and then following that, it's just more based on your understanding of what completing the square is, but the actual calculations are not too bad in parts B and C. So let's have a look. So it says write the following function in the form a times x plus h squared plus k. So that is a way of telling us to write it as a completed square. So to complete the square, we want to get it down to a single x squared. So we're going to take 2 out as a common factor. So we can have our function is equal to 2 times x squared minus, now 2 doesn't go into 7, which is going to make it a little bit messier. So minus 7 over 2x minus 5. Okay, so we can't drop that 2 on the outside. We must keep that there. Now we have the single x squared inside this bracket here. We're going to want to complete the square inside there. So let's keep our 2 on the outside. And then to complete the square, we'll make this x. Keep the sign. So you're going to half your x coefficient. Okay, so you have x minus half the x coefficient squared. Then we need to subtract the half the x coefficient squared again, so outside, so like this, and then we keep our minus 5 afterwards. So I have another video which goes into completing the square in detail as well if you need to look back on this. So from here what we'll do is we have 2 times, we'll keep that as it is, the x minus 7 over 4 squared. Go back there. Then this will be minus, we have to square this out and we get 49 over 16, and then we have minus 5. So we're going to need to tidy that up. So minus 49 over 16 minus 5. Might just put that into my calculator. Minus 49 over 16 minus 5. So that's minus 129 over 16. So we have this is equal to 2 times x minus 7 over 4 squared minus 129 over 16. We're pretty much done. There is one thing we need to do then with this, which is multiply our 2 by each of these. Okay, so that will then give us 2 times the bracket, so x minus 7 over 4 squared, and 2 times this will be the same as just half in the bottom of the fraction, so it will be minus 129 over 8. Okay, so that is in this form that they wanted up here, which is our completed square form. So that's the main hard part of the question. The next bits are just to do with our understanding of completing the square. So to find the minimum point is going to be when this is equal to 0, because the smallest a square can be is 0. Any real number squared is never negative. So the smallest it can be is 0. That will be when x is equal to 7 over 4, because that will give you 0 inside that bracket. And if this whole thing then is equal to 0, then the entire function would just equal minus 129 over 8. So we should then write this as a point. So it will be 7 over 4 minus 129 over 8. Okay, so then says explain why this must have 2 real roots. So there's a couple of ways you can do this, but in general, when we see 2 real roots, we should be thinking of our discriminant, which is our b squared minus 4ac. For this to have real roots, this must be greater than or equal to 0. So for this then, we'll go back to the original equation up here. Okay, and we can say then that b squared is minus 7 squared minus 4ac. That's equal to 49. That will then be plus 40. Well, it won't be plus 40, it'll be plus 80. So plus 80, that's equal to 129, which is greater than 0. So therefore it has two real roots. Okay, the other way of doing it is actually just following on from the previous part. So if we know this has a minimum point where the y value is less than 0, remember this is going to be a u-shaped graph because it's a quadratic with a positive x squared. If it's a u-shaped graph and its minimum is below the x-axis, that means graphically it must cut the axis twice, which means it has real roots. They are actually real and different as well. So you could show it graphically from above. We would just say that the minimum point is below the axis and it's a u-shaped curve. Always spell out to the examiner in as much detail as possible. So I wouldn't just draw on the graph, but we can say u-shaped curve, minimum point below the x-axis. Therefore, the graph must cut the x-axis twice. Therefore, it must have real roots. So write the roots of the equation in this form. So if you got to this point of the question and we hadn't got the completed square at the start, you could use the minus b formula from the start to find this, but this is actually a little bit easier if we just take our completed square. We're pretty much there. You just have a couple of steps to do. So you have 2 times x minus 7 over 4 squared, and then minus 129 over 8 equals 0. Now, I'm going to run out of room myself here, but we'll go down below. So then that will be 2 times x minus 7 over 4 squared equals 129 over 8. So what we can do then is divide by 2. So you'd have 2 times, or 2, divide by 2, x minus 7 over 4 squared is equal to 129 over 16. So then what we can do with that is take the square root of both sides. So you'd have x minus 7 over 4 is equal to, and if you're going to take the square root of this, you need to take plus or minus the square root of 129 over 16. Now, if we then want to bring that 7 over 4 over, what we'll see is the following. So let's just go up here. X is equal to 7 over 4 plus or minus, and this will be the square root of 129 over 16. And does that work? So they want it as p plus or minus root q. They tell us these are only minor details, but p and q are elements q, so they're both rational numbers. So this is 7 over 4 plus or minus, so it is a rational number, 7 over 4 plus or minus the square root of another rational number, which is this. So that would be our final answer for this. So a nice algebra question there, not stuff that's asked all the time. So it does need to have a good, you do need to have a good knowledge of the ideas of completing the square and also real roots, but the actual calculation parts themselves are not actually too bad.